Hey everyone, welcome back to the channel. Have you ever wondered why you stay logged into websites like YouTube, even after closing your browser or restarting your computer? You just open it up and boom, you're right back where you left off. It feels like magic, right? Like the website just remembers you. But how does it actually work? What's the secret behind this persistent login? Today, we're going to pull back the curtain and demystify this everyday digital magic. We'll dive into the world of security, identity, and authentication using some fun real-world analogies to make it all crystal clear. Let's get started. To understand how a website remembers you, we first need to understand a fundamental concept about the internet. The core protocol that powers the web, called HTTP, is what we call stateless. Imagine you're talking to someone with severe short-term memory loss. Every single time you say something, they immediately forget who you are. You'd have to reintroduce yourself with every single sentence. Hi, I'm Alex. Can you tell me the weather? Hi, I'm Alex. Can you show me the news? Hi, I'm Alex. Can you play that cat video? That sounds exhausting, right? Well, that's exactly how the web works by default. Every request you make to a website, clicking a link, loading a page, liking a video, is a completely separate, independent event. The server has no inherent memory of your previous actions. So, if the web is naturally forgetful, how do we build a system where it can remember us for days, weeks, or even months? The answer lies in a clever trick involving something we call state management. Let's use a metaphor to make this easier to grasp. Imagine you want to enter a secure members-only office building. The first time you visit, you go to the front desk. You show them your ID, they check your name against a list. Maybe you provide a secret password you set up earlier. This process of proving you are who you say you are is called authentication. Once the receptionist verifies your identity, they don't want you to repeat this whole process every single time you want to enter a different room in the building. That would be incredibly inefficient. Instead, they give you an electronic keycard. This keycard is your pass for the day. Now you can freely walk around, tap your card on the readers, and access all the areas you're permitted to enter. You don't have to show your ID at every door. You just present your keycard. This is almost exactly how logging into a website works. The first time you log in with your username and password, you're at the digital front desk authenticating yourself. The server confirms your credentials are correct. Once verified, the server doesn't want you to re-enter your password for every single page you visit. So it hands you a digital keycard. In the world of web development, this keycard is typically a small piece of data called a cookie or a token. This cookie is then stored by your web browser. Now, for every subsequent request you make to that website, every click, every page load your browser automatically includes this cookie, this digital keycard. When the server receives your request, it looks at the cookie, validates it, and says, I know who this is. This is the user who logged in earlier. Access granted. This continuous process of presenting the cookie and the server recognizing it is called a session. As long as you have that valid cookie, you maintain your session and stay logged in. So the cookie is the key. But what's actually inside this little piece of data? Is it storing your username and password? Not usually. That would be a huge security risk. If someone stole your cookie, they'd have your actual password. Instead, cookies typically contain a unique, long, random string of characters called a session ID or a token. Think of it like a unique serial number on your keycard. When the server generates this token, it stores a copy of it on its side, linking it to your user account. For example, it might have a table that says, token XYZ123 belongs to user Alex. When your browser sends the cookie back, the server just looks up that token in its database. If it finds a match, it knows it's you and lets you in. This way, your actual password is never stored or transmitted after the initial login. It's much more secure. The server is the only one who knows which token belongs to which user. Your browser is just a dumb carrier, holding onto the token and showing it whenever it's asked. Now let's talk about that Remember Me checkbox. When you check this box during login, you're essentially telling the website, please give me a long-lasting keycard. If you don't check it, the server might issue a temporary keycard accession cookie that expires as soon as you close your browser. It's like a visitor pass that you have to return at the end of the day. When you close the browser, the pass is gone and you have to log in again next time. But when you check Remember Me, the server issues a persistent cookie. This type of cookie has an expiration date set far in the future, maybe in a month or a year. It's like getting a long-term membership card. Your browser will save this cookie on your computer's hard drive. So even if you shut down your computer and come back a week later, the cookie is still there. Your browser will pick it up and send it along with your request, and the server will welcome you back without asking for your password. So logging out is simply the process of destroying this keycard. When you click the logout button, your browser sends a final request to the server. The server then does two things. It invalidates the token on its end, essentially deleting its record that token XYZ123 belongs to user Alex. And it instructs your browser to delete the cookie from your computer. Now, your keycard is gone from both sides. It's been shredded. The next time you try to visit a protected page, your browser has no cookie to send. The server won't recognize you, and it will redirect you back to the login page to authenticate all over again. This ensures that no one can use your old session to access your account. Let's recap what we've learned. The web is stateless, meaning servers are naturally forgetful. To create a logged-in experience, we use a system of authentication and session management. Logging in is like showing your ID at a front desk. The server then gives your browser a digital keycard called a cookie or a token. Your browser sends this keycard with every request to prove your identity. The Remember Me feature uses a persistent cookie with a long expiration date, so you stay logged in across sessions. And logging out is the act of destroying this keycard on both the server and your browser. This entire dance of passing tokens back and forth is what allows for a seamless, secure, and persistent experience on the modern web. It's not magic, but a very elegant engineering solution to the web's inherent forgetfulness. But this brings up a fascinating new question. We've talked about how you, a human using a browser, can stay logged in. But what about programs? What if I want to write my own piece of software that needs to communicate with another service? Like an app that automatically fetches my latest YouTube analytics? My program doesn't have a browser to store cookies in. How can my program log into YouTube's services and prove its identity to make these remote calls on my behalf? How does a machine authenticate with another machine? That's a whole different ballgame involving something called PI keys and OAuth, and it's the gateway to building powerful, interconnected applications. We'll explore that exciting topic in a future video. Thank you so much for joining me today to unravel the mystery of persistent logins. I hope this explanation was helpful and gave you a new appreciation for the clever engineering that powers our daily online lives. If you enjoyed this video and learned something new, please hit that like button and consider subscribing for more deep dives into the technology that shapes our world. Let me know in the comments if you have any questions or what other tech mysteries you'd like us to explore next. Thanks for watching, and I'll see you in the next one.